Okay, you were asked to prove that n cubed minus n is divisible by 6. Well, many of you, I gave you the hint to start off with n is even, n is odd, and just play around with that. So I'm going to show you the n is even and the logical thinking, but I didn't get a chance to clean this up. So it's going to be sloppy, and hope you can walk through with me and ask me questions if you don't understand what's going on. First, if I assume that n is even, then n is of the form 2 times k for some k belonging to the integers. No cell phones, no laptops. Sorry. I had to remember to put my own cell phone away. I was like looking at my messages going, oh yeah, put it away. It's pretty bad when the teacher's doing it too. Once we assume n is even, we drop it into n cubed minus n, kind of like we did on the in-class assignment, just to see what's going on. We know that 2 already divides that mess because there's a 2 that I can factor out. So really all I need to show now is that 3 divides that mess as well. Then 2 times 3 will divide the mess. So why does 3 divide, in fact, I had to look at the k later, but why does it divide the rest of the terms? Well, I went and looked at the sequence. I'm an experimentalist. I like to see those numbers. I don't always do it. So there's some of you here that really need to see those numbers. That's great, fantastic. I just spit them out into Excel and looked at k, 2k minus 1, and 2k plus 1 to try to see if one of those numbers are going to be divisible by 3. And then I saw a pattern. I saw that you see this perfect staircase of which of these 3 ended up being divisible by 3. So that started me thinking along the lines of induction. From if I know that the first one, the 2k plus first, the one on the right, was divisible by 3, then maybe I can prove that the middle term is going to be divisible by 3 on the next round. And maybe if I know that k was divisible by 3, maybe I can prove that 2k plus 1 was divisible by 3. So maybe I can run through the staircase from what I'm seeing here experimentally. So my conjecture is that 3 must divide k, 2k minus 1, or 2k plus 1. And not just must divide those 3, it must actually divide them in a particular order. That's what I saw experimentally. So if I could say it staircase-wise, this is sloppy induction. So this is scratch work for induction. Really, I'm trying to show that if 3 divides 2k plus 1, then what I saw in this round, 3 divides 2k plus 1, in the next round, it turned out that 3 had to divide 2k minus 1. So can I get from here to here? That's the first step. And this is my sloppy work, so sorry for that. Sloppy induction starts. I'm going to assume that 3 divides 2k plus 1. And I want to show that 3 divides 2k plus 1 minus 1. And indeed, when I take 2k plus 1 minus 1, I get exactly back to 2k plus 1, which I already know 3 divides, which is exactly what my experiment told me before. See? Look over here. Whenever 3 divided this one over here, it turned out to be the exact same number in the next step. 9, 9, 15, 15. So my algebra just verified what I saw experimentally. Make sense? Are you just saying that to make me feel good? Because I feel like this is really sloppy. It's not my usual polished slides. So what about the other one? Like if 3 divides k, can I prove that the next step works, that 3 divides 2k plus 1 plus 1? Again, going back to my experiment, that's what occurred here. Whenever 3 divided k, it turned out in the next step, 3 had to divide the rightmost cell over here. Well, I just ran the algebra through to see if it works. 3 divides k means k is 3 times s for some s, right? Drop it into the expression on the rightmost side, 2 times k plus 1 plus 1. Well, what happened is I got 6s plus 3. That's certainly divisible by 3 because I can factor out the 3. So it's sloppy, I didn't take out the 3, but you should get the point that now I've shown that I can get from one step to the other. So that verifies it, in a sloppy way, because in induction I'd have to show first that the staircase works for the first round, and then I'd have to show in general that it works from each step. And now you can assemble the proof. So I'm going to provide a clean proof for you that's handwritten on a piece of paper, and I'll post it. But you should be able to get the idea, I think, from here of how the process went. Case 2 is absolutely the same. I would do exactly the same. Once I got it figured out for one case, I pretty much know what to do for the other one. I do the same thing. I stick in n equals 2k plus 1, and I'm going to put it in the expression and see if I automatically get a 6 to factor out. If I don't get a 6 to factor out, then I'm going to have to go through some of the work I did just now, run the numbers and see if I can see a pattern.